students, our next topic is this complex algebra method. So what we already what we studied are graphical methods for velocity analysis. We studied relative velocity method or velocity triangle method, then instantaneous center method. Both are graphical solutions. Both provide graphical solution. So then when their graphical methods are exist, we have also non-graphical methods. So what are non-graphical methods? You have to study some non-graphical methods also. So two important such methods you have to study. First one we will go through today, that is the complex algebra method. There is a space, okay, when you write it, a space between that, complex algebra method. So what is the if we compare both methods, what we can say, in case of graphical method, first disadvantage is the accuracy depends on the person, right? So because if you all of you are drawing velocity triangles, if you measure for the same question the triangle, each one will be different. Probably someone may got 3.4 centimeters one side, other may got 3.5, some may 4, like that. So accuracy is depends on person. That is one disadvantage. And second thing, accuracy is limited. Okay, what we can use our scale to measure the one side. One side equal to velocity. Okay, 3.4 centimeter means some meter per second. That you have to understand. That's centimeter. Then, so what we can measure is only 1 mm is the accuracy. We cannot go beyond 1 mm. So that is the next point. So these two disadvantages can be eliminated in the non-graphical method, where we use equations instead of graphical diagrams. We use equations to solve for different velocities. Then what we'll get will be the most or completely accurate values and for maximum precision. Okay. Then what was the advantage of graphical method? It is simple and use very little time. These are the advantages of graphical methods, because for example, a slider mechanism or 4-bar mechanism, we have to draw just 3 lines. Okay, 1 line with the measurement and 2 lines with the direction. That then we finish our analysis. Just to measure the both sides and write it. That is your answer. That is the simplicity of graphical methods. So here it will take more time. We have to use a lot of equations and all, but the answers will be more accurate. So first one is complex algebra method. Next method you have to study is chase solution. Okay, that will be covered in another lecture. So here we will see complex algebra method for 4-bar mechanism. So all these methods we will see for both 4-bar mechanism and the slider crank mechanism. Okay. So here we use the complex number concept to form equation. That's why it is called complex algebra method, that we will see in the next slide. So here you can see a 4-bar mechanism. So I will name each link L1, L2, L3 and L4. Link 1, link 2, link 3 and link 4. Here you can see line, each link we have an arrowhead at one end. So you just draw simply a 4-bar mechanism. There will be no arrowhead, 4 lines forming this closed loop. But here I draw an arrow because we are representing each link as a vector. So we are putting an arrowhead. So for L2 I put an arrowhead. For L3 an arrowhead in the same direction, continuing the same direction. L4 also. Then the closing loop we are forming in the opposite direction. So this forms a closed loop of vector. Okay, that is the first step. I can show you a simple diagram without arrow, but I am directly showing this. Okay, first you can assume that one with no arrows, then you draw it as arrows and form a closed loop. That is the first step. So this is a closed loop, and from this you have to write an expression. That is the second step. What expression you can write? This is somewhat something like, velocity polygon or force polygon. So similar to a link polygon. Okay, that is we are moving in one direction and closing in the opposite direction. That is the concept of polygon. Then what equation we can write is, we have L2, vector L2 plus vector L3 plus vector L4 minus vector L1 equal to 0. So, right, for closed loop it will be 0. So what you can write is L2, L3 and L4 are in same direction. So you can put plus. So add L2 plus L3 plus L4 and minus L1 equal to 0. That is a expression or equation you can write from this diagram. So this is your first step, that is called a loop closure equation. Please note on loop closure equation. L2 vector L2 plus vector L3 plus vector L4 minus L1 equal to 0 or equal to L1. Okay, this is your first expression. Note it as loop closure equation, LOOP hyphen closure equation. Okay. The next step, so you are confused with all these, I'll explain one by one. The same thing I wrote here on a board, L2 plus L3 plus L4 equal to L1. That is the first step. Okay, you don't need to write again. You already wrote it in the previous here. Okay. Next, you see this expression. For a vector can be written in terms of exponential function such that a vector L equal to, generally vector L equal to magnitude of the vector L, small l into e raised to I theta. Okay, this is an expression you're supposed to know. So here we have 4 vectors, so you have to substitute this expression in each of them. That is the second step. So next step you have to write, first you write this since L equal to L vector L equal to small l into e raised to I theta. What will be vector L2? L2 into e raised to I theta 2 plus L3 e raised to I theta 3 plus L4 e raised to I theta 4 equal to L1 e raised to I theta 1. Clear? That is the second equation. Next step is, you have to differentiate this expression with respect to time. Okay, differentiate the expression with respect to time. See, for better view only, I am wrote different color for each line. Okay, there is no other significance for the color. That's only for better viewability. Then differentiate with respect to time. So when I differentiate first one, L2 e raised to I theta 2. What is L2? L2 is actually magnitude of vector L2. What was vector L2? It is corresponding to the link 2. So the magnitude of that vector means the length of that link. So L2 is the length of link 2. That is your crank. Okay, check your diagram. L3 is the length of your coupler. L4 is the length of your rocker or output link, and L1 is the length of your fixed link. So what means these all are constant. So L2 is a constant, so that differentiation will be L2 into, what is the differentiation of e raised to a function? Same, e raised to. So differentiation of e raised to I theta 2 is e raised to I theta 2 into theta 2 is a function. You have to differentiate that function. Differentiate theta 2 with respect to time. So L2 e raised to I theta 2 into d theta 2 by dt, or differentiation of theta 2 will be your differentiation for first term. Then for the second term, L3 e raised to I theta 3 into d theta 3 by dt plus L4 e raised to I theta 4 into d theta 4 by dt. Okay, equal to 0. That is a, again I skipped one line that I will explain. Is supposed to be equal to what? L1 e raised to I theta 1 into d theta 1 by dt. Differentiation of theta 1 by dt. But this d theta 1 by dt will be 0. Now you think why? You check your diagram. What is theta 1? Theta 1 is supposed to be the inclination of link 1. Okay, or the rotation or whatever corresponds to the rotation or inclination of link 1, that is theta 1. Now check, link 1 is your fixed link. So fixed link have no rotation or no motion at all. So fixed link is fixed. That means theta 1 is 0. Okay, otherwise it is a constant. No need to be 0, but it is a constant. Then when it is a constant, constant means d theta 1 by dt will be 0. So that's why I'm a direct. If you want, you can write first the same thing, L1 e raised to I theta 1 into d theta 1 by dt. Then next step you can write or in equal to 0, that you can add in the same what equation. Otherwise you put it in here, since you put write it as 0, and in box you put since it d theta 1 by dt equal to 0. That is the next step. Okay, clear. Next step, what is this d theta 2 by dt, or simply what is d theta by dt generally? So d theta by dt for a rotating link will be its angular velocity. Okay, you just imagine that the crank is rotating, so the rate of change of theta will be your angular velocity. Therefore, what we can write, d theta by dt will be omega 2, d theta 3 by dt will be omega 3, and d theta 4 by dt will be omega 4. Similarly, d theta 1 by dt will be omega 1, but in this case omega 1 is 0. That's why it's not here, it will be 0 here. So that you are, in terms of omega, you are writing the same equation. That is your next step, L2 omega 2 e raised to I theta 2 plus L3 omega 3 e raised to I theta 3 plus L4 omega 4 equal to 0. Okay, clear. Then next step, in the next step you have to use this equation. This is also you supposed to know. E raised to I theta can be written as cos theta plus I sin theta. Okay, then you substitute or replace all exponential terms with cos and sin theta. So the first term is L2 omega 2 e raised to I theta 2, that is replaced by cos theta 2 plus I sin theta 2 plus L3 omega 3 into cos theta 3 plus I sin theta 3 plus L4 omega 4 into cos theta 4 plus I sin theta 4. I is missing, please write I here. Okay, please write I here, it is missing. Cos theta 4 plus I sin theta 4. Okay. Okay, I sin theta 4 equal to 0. So in the next step, you have to add what you write separate the real and imaginary part. In this case, cos theta is your real part and sin theta is the imaginary part. Okay, that is also knowledge you supposed to know. So you are rearranging such that rearranging real term and what imaginary term. So in this case, if e raised to I theta is 0, what we can say, real term will be 0 and imaginary term will be 0. That is, cos theta will be 0 and sin theta will be 0. So here, if you add the all real terms here, it will equal to 0, and all imaginary term, that will also equate to 0. So next step, L2 omega 2 cos theta 2 plus L3 omega 3 cos theta 3 plus L4 omega 4 cos theta 4 equal to 0. That is only real part of this equation. Then next you write the imaginary part. Imaginary part is coming with I. So with I we have L2 omega 2 sin theta 2 in the first expression. Then we have L3 omega 3 sin theta 3 plus L4 omega 4 sin theta 4 equal to 0. That is the next equation. So I wrote it as equation number 1 and 2. Okay. So the next step, you multiply, you have to eliminate one term from this expression, because we have two unknowns you can solve, but here we have three unknowns. correspond, we can say omega 2, omega 3 and omega 4. So one unknown you have to eliminate. So which one will you eliminate? We have to eliminate omega 3 here, because omega 2 is our crank crank velocity, and omega 4 is our rocker velocity, or omega 2 is input velocity, omega 4 is output velocity. So we always concern, or most of the case we concerned with input and output velocity. Even it is interchange. Sometimes omega 4 will be input and omega 2 will be output, but omega 3 is always an intermediate thing that we don't require many cases. Therefore, to find our objective is always find output velocity, so we need only the omega 2 and omega 4, so you can exclude omega 3. So to do that, what you have to do is you have to make the cos theta 3 term or omega 3 term same in both expression. Okay, so in the first expression it is L3 into cos theta 3 into omega 3, second L3 into sin theta 3. So for that we have to multiply sin theta 3 with equation 1. So multiply sin theta 3 into this equation. Similarly multiply cos theta 3 into this equation. Why we are multiplying sin theta 3 with the first expression? In the second expression we have sin theta 3 as the term with omega 3. In the first expression we have cos theta 3 with omega 3. Therefore, to make the both terms same, we are multiplying second expression coefficient into the first equation and first equation coefficient into second equation. Okay, so you do that, then what you can write is L2 omega 2 cos theta 2 into sin theta 3 plus L3 omega 3 cos theta 3 into sin theta 3 plus L4 omega 4 cos theta 4 into sin theta 3. On all terms sin theta 3 is added. Theta 3 is added equal to 0. There will be no change. Then next L2 omega 2 sin theta 2 into cos theta 3 plus L3 omega 3 sin theta 3 into cos theta 3 plus L4 omega 4 sin theta 4 into cos theta 3. Again cos theta 3 is added in all terms and right hand side is 0. So these are 3 and 4. Okay. Result of 1 into sin theta 3 is 3. 2 into cos theta 3 is 4. So here you can see both coefficient of omega 3 in both expression is same. What is that? L3 cos theta 3 sin theta 3. Now you subtract 4 from 3. Okay. So 3 minus 4. Then what you can say? This term will be eliminated, because we have L3 omega 3 cos theta 3 into sin theta 3 minus L3 omega 3 cos theta 3 into sin theta 3. So this term becomes 0. So you will get the remaining thing. Okay. So this is that subtraction. Do that 3 minus 4. So I wrote this all steps. So L2 omega 2 cos theta 2 into sin theta 3. That is a term on 3 minus term on 4. L2 omega 2 sin theta 2 into cos theta 3. Then these two terms plus and minus. Then finally these two terms plus and minus. Okay, L3 omega 3 cos theta 3 sin theta 3, again cos theta 3 sin theta 3, here cos theta 4 sin theta 3 and sin theta 4 cos theta 3 equal to 0. So the second line, this term will be 0 because these both terms are same. So it becomes 0. Remaining is first line and third line. Okay, here in your expression you can note it as 0. The next step you can write these two, first and third line. Now you see the first line. Now after this only, okay. Next step I am telling. The first line. Read this. This is L2 omega 2 into L2 omega 2 is common. So L2 omega 2 into, put a bracket, open a bracket, cos theta 2 sin theta 3 minus sin theta 2 cos theta 3. Or I will say sin theta 3 into cos theta 2. Okay. Minus sin theta 2 into cos theta 3. Now you think what is the answer? We have sin A sin B, sorry, sin A cos B minus cos A sin B. Clear? This is that. Therefore, what is the answer? It will be sine A minus B. This thing also you supposed to know. Okay. So sine A minus B. That is A is theta 3 here. B is theta 2. So what we can write? Sine theta 3 minus theta 2. Similarly, when it comes to the third line, these two terms, we have L4 omega 4 common. In bracket, we have sine theta 3 into cos theta 4 minus sine theta 4 into cos theta 3. That is sine A cos B minus sine B cos A. Again sine A minus B. Here A is theta 3, B is theta 4. So sine of theta 3 minus theta 4. So you write that in the next expression. L2 omega 2 sine of theta 3 minus theta 2 plus L4 omega 4 sine of theta 3 minus theta 4 equal to 0. So in the next step, take L4 omega 4 term into the right hand side. So you can write L2 omega 2 sine theta 3 minus theta 2 equal to minus L4 omega 4 sine theta 3 minus theta 4. The next third line, you have to eliminate this negative sign. So if you multiply into sine, what we can write is sine theta 3 minus sine theta 3 minus sine A will be sine minus A. Okay. Then when you apply that, you will get L2 omega 2 equal to sine theta 3 minus theta 2 equal to L4 omega 4 into sine theta 4 minus theta 3. Instead of theta 3 minus theta 4, we are eliminated the negative side. So this is your pre-final expression. Okay. So hope this is clear. Then the last step, what we have to find? Actually, what we have to find is omega 4. Omega 2 will be our input, omega 4 will be our output. So you have to find omega 4. So you write an expression for omega 4 from this equation, this expression. Okay. So write omega 4 equal to, take all the terms, all the coefficient to the other side. What we will get? Omega 4 equal to L2 omega 2 divided by L4 into sine theta 3 minus theta 2 divided by sine theta 4 minus theta 3. So this will be your final expression. Okay. Omega 4 or our output velocity equal to input velocity omega 2 into L2 by L4 into sine of theta 3 minus theta 2 divided by sine of theta 4 minus theta 3. Okay. Put this in a box. This is your final expression. Okay. Now next thing is identify each term. Omega 4 we already mentioned, this is the output velocity. Omega 2 is the input velocity. What is L2? Length of link 2 or length of input link or crank. L4 is length of output link or length of rocker, or sometimes it is also another crank. Okay. Then we have sine function. We have theta 2, theta 3 and theta 4. What are these angles? Theta 2, theta 3, theta 4. That we will see in the next slide. So again we have the same mechanism. Okay. So here, what is theta 1? Theta 1 is the inclination of L1. So what is L1? L1 is the fixed link and this is horizontal. So the inclination will be 0. Clear? So directly you can write theta 1 equal to 0. And we are referring fixed link to measure angle. When I say theta 1 is 0, this is horizontal only. But even if I rotate the mechanism, say 45 degree, it is become 45. So it is related to the L1. So L1 is horizontal and it is 0. Okay. So all other inclination should be measured with the same horizontal. That's what I mean. Okay. All other inclination should measure with the same fixed link or horizontal. Now what is L2? L2 is the inclination of link 2. Now how will you measure that inclination? So L1 is measured along horizontal line towards right. So this is the positive x direction. You can imagine as the positive x direction. So you have to always measure inclination from this direction. So L2 will be this. Okay. So this will be theta 2. Clear? Because we are measuring from positive x-axis. Then why I am telling again and again the same thing, because for the next two link you need this knowledge. Okay, that's why. So if you consider L3, what will be theta 3? Theta 1 is 0. That also I will write here. Now what will be theta 3? Theta 3 will be the inclination of L3. So inclination you have to measure from the horizontal and positive x-axis. So I draw a line, horizontal line at the beginning of L3. Okay, the beginning of L3 I draw a line. Then I can measure theta 3 like this. This will be theta 3. Okay, clear, simple. Then finally we have L4. So in case of L4, you may make a mistake. That's why clearly listen properly. L4 is a link starting from here and ending here. When it is a vector, this is the starting point and this is the direction downward. So you have to measure the inclination of L4 with respect to horizontal. So I will draw a line at the beginning, and with respect to positive x-axis. So this is the positive x-axis towards right. So from this line you have to measure. So this line, how will you measure? Some may measure in this direction. Okay, from here to here, that is wrong. That you have to know. So when you measure from this direction, this is the only possible direction. Then you have to measure like this. Clear? This is theta 4. Clear? So we found theta 1, theta 2, theta 3 and theta 4. So in the question we'll have the details. So we have all dimensions, that is L1, L2, L3 and L4, and we have to find theta 1, theta 2, theta 3 and theta 4 by some method. Then omega 2 will be given in the question. Then only unknown in the your final expression will be omega 4, that you can find. Okay, this is how the method should be used. So we will solve a question the next lecture. Also we will discuss for Sider crank in next lecture. Okay, thank you.